Hello everyone. Now I am going to define what the time series is. As we have seen in regression 1, we are going to define x and y. They are correlated arrays. That means x and y, both the variables are correlated with each other. Now here in time series also we are going to define two variables. One among of them is related with the time. That means it can be year, it can be month, it can be weekday, it can be quarter of year and all. Okay, so this one, in set of observations, one variable is associated with the time one and another one is associated with that time series. So this number of cars is related with the year, that is 26 number is associated with 2010. Then 30 is number defined as 2011, 38 is for 2012, likewise. Okay, so this kind of data is known as a time series. Now how to define the time series? Time series is having four components. One is seasonal component, one is cyclic component, one is that variation we have already seen. Now we define the time series with the help of Excel. So first of all, we will define the time series plot. Again, as it is the plot time, we have to go for the chart options. Okay, so here we are going to define all the chart options. So define just the chart which is used for scatter. Okay, in the previous regression, we have used this dotted plot. Instead of that, I am going to define this line plot, scatter with straight line. Okay, or this one, scatter with straight line and markers. Any one of them can be work well. Okay, now here in this case you have to define your data. Add data. So series name is number of cars. Your x values are been defined as this one, x, and y values will be this. Okay, so this is what you are going to define. If it is not displayed, just delete that, select your data set first and then go for this insert option, xy plot, and this one. Either you can choose this plot or this plot. Both will work okay. Fine, I am choosing this first one. Here on x values we have taken this year and on y values we have taken this number of cars. Okay, now as the chart option opens, we can change the chart color also. From this, I'm putting this as a green one. Okay, then we can change the chart layouts also. From this, grid lines, legend and everything. Okay, this we have already seen as per our regression was there, isn't it? Fine. Now here trend line is also there. Okay, so if we want to define moving average, we can define that moving average on your trend line also. Just go for that. Another moving average line is there. Again, you can right click on that and change the layout of your this moving average also, or just go to plus sign, go for this trend line options, then more options. Now here we have only seen the linear one, linear trend line. Now you can observe our green line is quite different than this this another one. I am going to put this one as a different color so that we can differentiate this. Now you can observe this orange color, or should I put it as a blue so that it will be diffuse. Okay, so this green is what our actual time series is, and this blue line, which is a straight line, is nothing but our moving average or trend line, isn't it? So I'm going to put some more. Instead of putting linear, we can go for this polynomial one. That means in time series there is no need to go for only linear one. Linear means what? Sum y is equal to a into sum x plus intercept. That means x and y, both the variables at the same exponent 1. Okay, as we are having some curve structure, we have to go for polynomial one. If I am putting this order of this polynomial, order of that polynomial is nothing but the exponent that is using to define our trend line. Okay, so if I increase this polynomial, your shape of that polynomial is also going to change. Again, I can change the color of this line. I am putting it as a blue so that you can get actual idea. Okay, so here I am just increasing my order of that polynomial, and the shape of this polynomial is behaving like the actual one. This is what our actual calculation is going to be same that what actual we are having. Okay, now if I am going to use this display equation on chart and display r square, this equation on chart is going to define what equation of that trend line is going to follow. So first one, y is equal to minus 0.833 x cube. This x cube is defining the order of that polynomial. The highest power of your variable is 3. Okay, so that's why your polynomial is going to be 3. If you decrease that, just check, your equation of y is also going to change. That will be y is equal to some constant into x square minus constant into x, and so on. So here this blue line is looking or behaving different than the green line or green curve. Okay, here this defines the order. That order defines actual values, and the values which can be calculated with the help of equation are going to match with each other. So as I increase the order, the shape of that curve is also going to be in the same path. Okay, then here your r square value is nothing but the relation between actual values, actual green line and the blue line values. Okay, if you are increasing that r square and it is reaching up to 1 or near value to the 1, your equation and the actual behavior of values are going to be same. Again, if I increase the order of this 3, your equation is going to be y is equal to minus 0.4167 x raised to 4 and so on, and just observe your r square value is increased to 1. Okay, so here these x values and that dotted blue line is coinciding both the one. Okay, so this is what our time series analysis is. Now here forecast option is there. Now forward forecast means we have 2014 up to values. Now I can define this period up to 2. So just forward this to 2. Okay, so by clicking that we can have this equation up to 2015 and 2016. This one is your equation. Now this order has to be 3. Okay, so here your equation is going to be like this. Fine, this is what your forward equation. Now if I am putting this as a backward means as we are having values up from 2010, the backward will be the values of number of cars for previous years. So I am putting it as 2 also. So just enter this. You can have this one, that is 2012 का observation है, उसके पहले 20 2009 and 2008. This is how we are going to predict our time series. Understood? Okay, so this equation is going to be best fit. Another one we can use it from, this is what our graph says. Now another one we can use from this data analysis. Now we can use this exponential smoothing also. Go for this exponential smoothing. Now here we have to input the range from year 2010 to this one. Let's input proper range. Labels, damping factor 1. Now I need to use the output range. I am putting it here, or this will be here. We have to use the chart output. Okay. Instead of this 2010, I have to use this only number of cars values. Just check, these are here. Exponential smoothing. In this also we are going to have this graph values. Blue line is for actual and forecast values are for this defined with the orange color. This is all about our first chapter, this time series chapter.